Now let's review the symmetric multiprocessor systems, or SMP in short. So this system has this couple of characteristics. It has two or more compatible processor in the system. Like if you open up this computer box on the motherboard, you will find like multiple processor on that board. Okay, two or more. Then through the interconnect network, they are connected with a single main memory system, like single memory card, and bunch of IOs like USB port and network port and memory extension port, etc., etc. All IOs, and of course your monitor, keyboard, mouse, those kind of port. It's get connected to the interconnect network. So all the processors in that system shares their IO and memory resources between them, and their access is controlled by integrated operating system. So of course, like since they are the single resource, it doesn't mean that they can in truly in parallel way, like same time, like multiple access are going on the main memory. It's not that they kind of an interleaved access. So operating system controls that which processor get how much time on what resources and so on and so forth. So they kind of give us an illusion that you are really doing some multiprocessing in parallel, but from the resource perspective, they're basically serialized. Now, why they are important or why they can help us in improving performance? If you remember, your program, what you are running on a system, has two part. One is one part is doing purely data crunching inside the processor, and other part is basically communicating with the memories and IO systems. So in general, it is an input output part and data crunching part. So what we can do while one processor is busy in crunching data inside it, other processor actually can initiate a memory access or IO access. So in that fashion, it increases the performance of the system. So your performance is through the parallel programming, because you are basically making full utilization of the memory and IO resources. All the time it is busy serving one of the other processors, and processors also busy when if they get the data, they are busy in crunching them. So that good. Also, it implements redundancy in the system. Let's say you have like 10 processors, right? And they're all electronic system, electronic component. So they can go bad at any time. Like after 4 years, 5 years, usually system, like tendency to go bad is grows up almost like exponentially as time goes. So it might happen that one or two processor is down, just burnt out. In that case, since the system still has 8 other processor, your system won't be completely down. It will actually feel as a slowdown in the system, but it don't die down on you. Okay, you can still work, still you can run multiple program as it is, and operating system just adjust, knows like okay, two processor is gone now, so it will make sure that it takes care of everything using those remaining 8 processors. So that gives us some opportunity. Actually, if you now turn down the system as a whole, shut down, open up the box, replace the bad processor with a good processor, then you are good as new. So it's implement redundancy in the system. And even if online, when it is actually in between operations, one or two processor gone, burnt out, its processing continue. It continues with the processing, though with the less performance. Now incremental growth in the sense, now let's say this system had like 6 processor and you wanted to have, okay, maybe another 2 or another 4 depending on your business need. You see that you need more power crunching, more power to the data crunching. So you add 2 more processor or 3 more processor. Now there is a catch there. We are talking about one single motherboard, right? And we are talking about like putting new processor. So that really means the motherboard need to provide slots for the processor. If it didn't have like 4 more open slot when you have already 6 processor is there in the system, you cannot extend to like arbitrarily to 16 processor. You are limited to extend only to the 4 more processor because you have only 10 slot available there. It's the same as like if you open up your computer, like there are each computer has a memory extension capability, but it has an upper bound. It has an upper bound. So maybe you start with 4 gigabyte RAM, and depending on your system, maybe it says, okay, you can go up to 16 gigabyte. So that means that many corresponding slots, memory slots are available so that you can actually punch in new cards or add new cards, memory card to it and increase the memory. But you are limited by the number of slot availability. So they say it's an incremental growth feature, but we need to understand there is a catch. It is not infinitely incrementing. It has an upper bound, depending on how many additional slot available to you really to insert really the real hardware into the system. Now with that availability, like let's say 10 slot, 15 slot or 20 slot for the processor to go in, now you have really a scaling, right? You have the scaling means you have the range of products. Now you can probably some low price market you can offer, okay, 2 processor system, low processing, right? And then high end you can on the same board you just add like 16 processor and sell it as a high end system. So your production cost is same basically, but you are kind of tune up to your target market. You are going to sell it to the student community, cheaper computer, okay, 2 processor. You are going to home based business, okay, 8 processor. You're going to industry enterprise type system, 16 processor, and price varies out of that.